Hello friends, welcome to Smart Techie. Today we shall be dealing with first chapter of Geotechnical Engineering 1, that is Soil Origin and Nature, Formation of Soils. So the term soil has different meanings depending upon the profession we consider. If you talk to an agriculturist, he will say that soil is a substance existing on earth's surface on which he is going to cultivate his crops. If you talk to a geologist, he will say that soil is a material in which roots occur and the rest are rocks depending on hardness. If you consult to an engineer, he will say that soil is an aggregated deposit of minerals, organic particles covering large portion of earth's crust, and he will further classify them into boulders, sands, gravels, clays and silts. So soil is a complex material which is produced by weathering of solid rocks. Weathering is nothing but a process wherein a bigger rock is divided into smaller particles. It is also called as disintegration of rocks. Now this breaking can happen because of physical forces or because of chemical forces, based on which it is divided into physical weathering and chemical weathering. When it comes to physical weathering, we have the wind action, water action or freezing, which is nothing but ice formation. When it comes to chemical weathering, we have acid rain, we have rusting, processes like carbonation, hydrolysis, etc. So physical weathering is responsible for formation of cohesionless soil. Cohesionless soil is nothing but sand. If we hold sand into our hand, it will flow easily. That is nothing but cohesionless soil. And chemical weathering is responsible for cohesive soil. Cohesive soil is nothing but the soil which is sticky in nature. For example, clay. The particles are attached to each other, they are attracted to each other, and they will not flow easily from our hand. So weathering cycle consists of transportation, deposition and upheaval, again followed by weathering. We have another classification, that is residual soils and transported soils. Residual soils are those which remain with the parent rock at shallow depths. That is, after a particular rock breaks, the soil which is formed will be present there only. And transported soils are those, as the name says, are transported to different places with the help of water, ice, wind and gravity. For example, in the figure we see a lake which is flowing and which is carrying soil with it, which is nothing but alluvial soil, which is an example of transported soil. So alluvial deposits are those which are formed by running water. Lacustrine is by lakes, marine is by seas, aeolian is by wind and glacial is by ice. So when it comes to the history of soil development, the knowledge is there right from the prehistoric period. We have Rebhan, who dealt with earth pressure theory in the year 1871. Darcy studied about flow of water through soil in the year 1856. Bossini studied about stress distribution in the year 1885. Muher studied about representation of stress in the year 1871. We have Utterberg, we have Felinius, who have studied their particular theories. So all these theories will be dealt in geotechnical engineering in each unit. Their application is there in numericals, their application is there in all the units. So we'll be studying about all these theories step by step. So when it comes to soil mechanics, it is the youngest discipline of civil engineering which involves the study of soil, its behavior and application as an engineering material. Very important, we have Dr. Terzaghi, who is known as the father of soil mechanics. And soil mechanics is widely used in foundation design and construction, pavement design, design of underground and earth retaining structures, design of embankment and excavation, design of earthen dams, etc. Because of all these applications, soil mechanics as well as geotechnical engineering is considered to be one of the most important branches of civil engineering. Thank you.